Hi, greetings everyone. Thank you for joining us, Exchanging Ideas 32, Global 5G Evolution. My name is 𝗃𝗃cie𝗵𝗃 and I'm the founder of Global 5G Evolution. Global 5G Evolution is a 5G media and consulting company. We are a startup and we are new in the consulting industry. Global 5G Evolution, we build global 5G community with 5G ecosystem experts around the world, reaching 230 5G experts from 49 countries and growing more. From vendor, telco, mobile network operators, verticals, universities, research institutes, startups, and growing more. We provide a local perspective on global issues and continue to be at the forefront of 5G industry developments. Global 5G Evolution actively establish relations with countries around the world to build a constituency of mutual support, to exchange experiences and embark on joint bilateral initiatives to further strengthen 5G development. We can support organizations on brand visibility on an international platform by welcoming sponsorships and a direct access to the international institutions in 5G research and development, and also an exposure through our integrated marketing campaign via most active social medias that we have via the Facebook, Insta, Twitter, and LinkedIn as well. And we offer exclusive rights to special coverage, features, and interviews for a greater community reach out for these respective organizations. Now, coming to this presentation, the title of today's presentation from me is an overview of 5G advanced evolution in 3GPP release 18. The 3GPP RAN plenary recently approved a work package for its release 18. The work package includes diverse studies that will significantly boost 5G performance and address a wide variety of new use cases. And 3GPP release 18 will embrace AI and machine learning to provide a data-driven intelligent network solutions. Now, this is the 3GPP's 5G evolution roadmap from 5G to 5G advanced. And 3GPP continues 5G evolution in release 17, which is this area. And existing features such as MIMO, DSS, UE, power savings, coverage, and URLLC are further enhanced. The main new use cases include support for reduced capability UE, operation in frequency bands beyond 52 GHz, multicast and broadcast service, which is the MBS, and the non-terrestrial networks, which is the NTN. And release 18 will include 27 diverse studies that will further boost network performance and address new use cases, embracing the artificial intelligence and machine learning technologies in the evolution of 5G advanced. Now, this is the 3GPP release 18 features that will further enhance 5G performance. We have the multicast and broadcast, followed by enhanced mobility support, network energy saving, coverage enhancement, MIMO evolution, and improved positioning. Now, if we look at this area, energy cost has become a significant part of network operating expenses, which is OPEX, and reductions in network energy consumptions are imperative for operators to ultimately achieve the sustainability objective of net zero to help combat the climate change. And 5G new radios significantly more energy efficient in terms of energy consumption per bit than previous generations. And however, due to increasing dense deployment of 5G networks, the massive MIMO, much larger bandwidths, and support for more frequency bands, 5G networks would lead to higher energy consumptions if proper energy savings measures are not applied. Therefore, 3GPP approves a study network energy savings for new radio in release 18. Now, the other area is the coverage enhancement, because coverage is another key consideration for operators as it directly impacts service quality, CapEx, and OPEX in commercial deployments. Particularly, the uplink coverage is often found to be the bottleneck in commercial deployments. Now, the other area is the enhanced mobility support, where this is quite an interesting area because it's a distinct feature of mobile networks which offers service continuity to moving UEs. The other area is the MIMO evolution, because it has been observed in commercial deployments that UE with medium or high mobility experience significant performance loss in multi-user MIMO scenarios, partially due to the outdated channel state information. Potentially, the CSI reporting enhancements will be explored to improve performance for UE with medium and high mobility. Now, the other area is the MBS, which is quite popular. Multicast and broadcast is quite a popular features among the broadcasting, and it's dedicated and delivering the multicast and broadcast services efficiently. And those use cases examples include TV broadcasting, live video, software updates, and public safety usage. 3GPP release 18 will extend to multicast support to UEs in RRC inactive state. And lastly is the positioning. Positioning is a valuable service that can find applications in diverse 5G use cases. And 3GPP release 18 will investigate solutions to further improve the accuracy, integrating, and power efficiency. And also in study side link positioning and investigating the positioning support for the rate cap devices. Now, this is 3GPP release 18 features that enable more flexibility spectrum use in 5G deployments. I'm not going to go to the details yet, but what I would like to stress that the 3GPP release 18 will introduce further enhancements to enable more flexible and efficient spectrum use for 5G deployments in various scenarios with different spectrum allocations. And it is expected that more and more spectrum bands used by previous generations of mobile networks will be refarmed to be used for the 5G advance. And the available of spectrum blocks will likely be fragmented and scattered in different frequencies, and aiming to efficiently utilize all available spectrum blocks flexibly. And 3GPP release 18 will introduce a single downlink control information for schedule multiple physical downlink shared channels. Now, if we look the other slide, this is just to give a feature that will expand 5G capability to serve the diverse devices. And as you can see, these are the key areas. And 5G needs to serve diverse devices across the enhanced mobile broadband, the UR-LLC, and the MMTC usage scenarios. And 3GPP release 18 will continue to study and introduce the tailored functionalities to enhance and expand the 5G capability to serve not only smartphones, but also the other 5G devices, such as the extended reality, the cloud gaming devices, low complexity UEs, vehicular devices, and the UAEs as well. And lastly, I just want to stress out is coverage, because coverage is crucial for operators to provide the competitive mobile devices to their customers. And deploying full stack base stations in coverage holes is a common way to improve network coverage. Still, it may not be possible due to, example, lack of backhaul, economically not viable. And this calls for a flexible network topology by increasing the resiliency of the split next generation RAN architecture. And it's exploiting the diverse nodes such as the IAB nodes, the RF repeaters, relays, and integration with the NTNs. And 3GPP release 18 will enhance the NR operation over NTNs by improving the coverage for NL terminals, the studying deployment above the 10 gigahertz, and also the investigating regulatory requirements for network verified UE location and addressing mobility of service continuing between a terrestrial network and a non-terrestrial network, as well as between the different non-terrestrial networks. So this is overall my presentation today on the 3GPP RS release 18. So without due delay, let me introduce the next speaker. I would like to introduce 𝗘𝘃𝗽𝗽𝗃 Choudhury from Washington, DC, US, to present on the network slices of network secure environments to operate. Over to you, 𝗘𝘃𝗽𝗃.
I hope you can see my screen.
Yes, sir. It works well.
Perfect. Perfect. Good morning, good afternoon, and good evening to everyone. Thank you, Ganesh, and everyone on this session for this opportunity. Listen and learn from everyone. And my name is Deepak. I work at Accenture as an emerging tech lead for 5G and Edge. And today's my topic is 5G network slicing. So I would like to cover all these topics on network slicing, but with only 10 minutes, I will try to cover as much as possible and may have to leave some of the content for the next time, probably in part 2. So let's get started without any delay. How is network infrastructure evolving? In the past, we all know systems have worked in silos, and with old rule of single service router suffice network architecture. Most of the networking function in the old system are built in a way that inherently brings insufficient resource utilization. Previous telecommunication network hosted different services such as mobile broadband, voice, SMS over the same network pipeline, which means not utilizing the resources efficiently for the service it carries the way the new technology 5G carries. With the latest network slicing in 5G, we can provide different variety of services based on use case requirements. Selecting optimal network resources each slides provide better utilization. Hence, this helps to achieve better CapEx and OpEx. Let's jump on the next slide, network slicing. Network slicing is an operator's best answer for the emerging tech use cases, evolving 5G, massive IoT, real-time edge computing, low latency, and high bandwidth. The network slice is logically separated, self-contained, and independent part of network, targeting specific service based on speed, data rates, latency, connectivity, and reliability. In other words, we can say it is a single physical network infrastructure, contains several virtual customized network pipeline to deliver services based on required SLAs or KPIs, key performance indicators such as latency, data rate, connectivity, and reliability. A network slice can be dedicated to one enterprise customer or shared by multiple tenants upon the business purpose it serves. For instance, a network slice for a critical IoT use case may require low latency, high bandwidth, and best reliability. In contrast, a heavy IoT use case will require higher latency and lower bandwidth. And if you compare with another video streaming slice, we will need only higher bandwidth. There is no requirement of low latency or number of connecting devices. I hope this helps the idea of network slices. Let's take a few examples to clear the network slicing term. And my option 1 here, we generally divide the slices in 3 main categories. As you have seen, Ganesh have shared the release 18 and release 17. We do see the more categories from emerging techs are showing just like vehicle to everything or critical communications. However, if you see this option, number 1, we have 3 types of main services based slices: enhanced broadband, ultra reliable low latency communication, massive machine type communication. And I divided this 3 use cases in 3 different colors: top, green, enhanced broadband, which serves the services like AR, VR application, gaming industry, fixed wireless access point. This virtual slice focus in mobile data bandwidth performance. Let's take a look quickly on second slice, the middle part of the orange, which is ultra reliable low latency communication. This is another most important slice for future case based on my assumption and my understanding. And this use case, the middle part, such as covers remote surgery, connected vehicles, manufacturing floors, where even milliseconds matter to save the life for the safety of our workers. And let's take a look on the third, the bottom one, the blue color, massive machine type communication. where machine to machine or a lot of IoT devices sending messages, data for any change in the services environment or in an OT infrastructure. Before I go to next slide, I'd like to add one more point. If you see these three slices, green, orange, blue, enhanced broadband, ultra low latency, and massive machine type communication, if you notice, the edge compute and core network user plane function is moving from central to local to edge network to the network edge. And that is the key differentiator how these use cases can be classified based on the different SLAs. And that's the very important point here. Let me take it to the next slide. And this is another example where you don't want to slice based on the class of services, but the type of client base or user base. Customization based on actual who is using the slice. In this option, I have divided physical network into network slices based on nature of the client, such as public services, such as public Wi-Fi, such as IoT devices, such as industrial or safety. This option share a physical network based on multiple tenants. This is just to show that we can provide slicing of a single physical network into multiple tenants. Let's move. I want to take another example. This is very close to me. I have worked this kind of use case in my past, where enterprise customer owns or lease a physical wireless network and disaggregate the physical network into slices based on the operation requirements. And again, in this, I have divided the multiple different various operation of mining into three categories. The first green block is for enhanced broadband, where you can see drones taking the video and sending the video to the data center or local servers within the mining area, or enterprise LAN or WAN networking, or AR/VR employee training. Second, the orange boxes you see on the screen of a mining operations, which is ultra reliable, low latency communication, where the equipment such as autonomous drill, which is the most important low latency application in the mining, autonomous vehicle moving inside the mining, which is also another most important use case, real-time truck telemetry, video surveillance, or tele-remote control from an operations center. Employees sitting in an operations center controlling the machinery outside in the mining. That requires ultra millisecond low latency communication. And the third, if you see the blue color boxes here, the third use case is massive machine type communication using IoT devices such as wastewater management, geofencing of people and assets monitoring. Those are all in blue color. So this gives a solid foundation that with network slicing, we can modify and customize the user SLAs and give what service we can give it using a physical network structure. With that said, I will take it to you next slide. And Ganesh, allow me when I'm crossing the time. Next slide. So I consider this is a very good slide, which helped me to dig deep on it, defining the overall approach. Which kind of slice? Where will be physical network element of the slice will reside either at central, local, or on premises. As you see, I have one column of area which shows you what kind of use case I want to work. And against second column, which gives you the latency, which will provide me what latency I need against which use area. And the same way, data rates in next column and the mobility. Knowing these SLAs requirement, one can plan and design a slice of a physical network. I hope this helps. This slice always help me. And let's discuss the benefits of network slicing. There are 4 to 6 main benefits here. Granular customization of use case requirement to achieve effective and satisfactory operation based on required SLAs. And that's what we have seen in our mining operations example, that granular customization of use case, we can help achieve maximum benefit of our refinery operations. Second, end-to-end network slicing enables new businesses model for innovations. And these days, communication service provider can create a service like network service as a slice, which they provide slice with different tenants as my option 2 example. Another benefit of network slices resources can be changed as demand changes. Hence, provides higher utilization of all the resources, which means I can improve OpEx as well as CapEx at the same time.
But time factor.
So these are the few benefits of network slicing, and I hope you enjoy the presentation. Thank you for your time.
Thank you, Deepak. That was very informative. Appreciate that. Let me introduce the next speaker. I would like to introduce 𝗦𝘂𝗽𝗍𝗂𝗧 from Budapest, Hungary, to present on how can telcos capitalize on metaverse. Over to you, 𝗦𝘂𝗽𝗍𝗂.
Thank you, and let me share my slides. Can you see it right now?
Yes, sir, it works.
Yes, so let me introduce myself. My name is 𝗦𝘂𝗽𝗍𝗂𝗧. I'm from PwC Hungary, senior consultant specializing for telcos, and I'd like to share some thoughts on how can telecommunication companies capitalize on metaverse. Obviously, it won't be exhaustive, but I will show you 3 examples and context of them. So first of all, just some really simplified examples what can 5G bring on the table for us. As you can see, the different generation of networks brought different B2C service offers. And in case of 4G, operators could already charge for higher bandwidth. And from device perspective, devices become smarter and smarter. In 4G, phones, tablets, watches, or the smart devices became popular. In case of 5G, we believe that telco providers will be able to charge for lower latency, higher reliability, and even for computing power. And the devices will provide more immersive experience. So we are thinking about, for example, VR devices. But what is metaverse? It is actually a phenomenon which is present for quite a while. Neil Stephenson mentioned first in its book 𝗬𝗧. It's a $13 trillion market, huge opportunity, and most of the corporate executive thinks that it will be business as usual in the next upcoming 5 years or so. It has many definitions as all emerging technologies, but how we define to our customers is that this will be a convergence of the physical and the digital network. It will focus on experience. It will be a world where one can freely explore, live, work, play together, shop, own stuff, and it will be a really immersive experience. It combines several key technologies of our decade. For example, on the infrastructure layer, it combines 5G, cloud computing, edge computing. On the data and transaction layer, it uses blockchain, data analytics, and AR. And on the experimental layer, it will be used VR and AR glasses, 3D engines, metaverse platforms, and so on and so on. At PwC, we have a metaverse framework which is built on 6 core principles. I don't want to go into really the details, but you can imagine a world where you go in, you have an avatar. This avatar has multiple belongings. It can shop clothes, accessories, or anything else. It has its own identity. This avatar can move belongings between different metaverses. And there are different rules in different metaverse platforms which are enforced automatically. What I really want to emphasize here the experience principle. So we believe that this will be a shared, persistent, and immersive 3D digital world. This will be an experience where everyone can go in and enjoy a 3D world. And if we take a look at what are the technical requirements of a multi-user VR or AR experience, users really have to feel that they are in that space. and they don't get sick using these VR glasses. This requires high resolution, wide field of view, low pixel persistence, high refresh rate, and even a lot of sensor data, optical calibration, movement tracking, and so on. This is, as you can see, a huge computing power. So we think that there are 3 ways for this, using this computing power. First one is that all the computing power is on the glass or on the device. This would make this device really uncomfortable. Second is that with some cable, the device is connected to an external computing source. This compromises the mobility of the whole technology. And the third one, which is the most viable solution, if we offload this computing power to the cloud. And since we need, this is a multi-user experience, we need really low latency for this computing power. So we are talking about edge computing here. I'd like to show you 3 ways how can telco companies play and how can they participate in the metaverse revolution. First is they are focusing on 5G services. Second, that they are building out edge computing capabilities. And third is something which focusing more on becoming an integrated service provider and developing metaverse platform. And obviously, this is not exhaustive. And obviously, telco companies can use more than one of these. But these are just a short introduction. How can they participate? So first, focusing on 5G services. Yeah, we already see that and know that almost every telco provider are building out their 5G capabilities. It's a huge market, a huge opportunity where a lot of subscriptions are coming in the next upcoming years. The main question: how can they monetize this opportunity? They can use it as they can use the traditional, which is the connectivity provider in this slide. This was what they tried to use in case of 4G, charging more for bandwidth, and they can charge more for low latency and higher quality of services. But it did not really work well in case of 4G. They couldn't really capitalize on that opportunity. They can use these B2B2X services where they are playing together with a third party in a solution enabler or a solution creator perspective or mode. The question is only who the customers are in contact with. But basically, these models are just a use case. We can imagine that we walk into a store, buy a VR device, and we get this VR device with a bundle with high bandwidth, low latency, and a lot of computing power, so we can use this in the metaverse. So taking on this and high computing powers, I would move on to build out edge computing capabilities, and I would emphasize 3 things on this slide. First is you can see that as you move the data center and the computing power closer to the end device, you will get lower latency. And in the case of edge computing, this can go down to 5 milliseconds, which is really good for this multi-user VR experiences. The second is that we believe that only a little processing power expected to stay at the end device on the long term for sure. And the third, which is I think really interesting, that if you look at the main use cases, 90 or 95% of them are B2B use cases. So AR and VR for entertainment and cloud gaming are the real B2C use cases, which can be widespread for a consumer perspective. And this is basically the basis of metaverse. So something that can telcos capitalize on the long term. And the third one is developing metaverse platform. So first of all, what is a metaverse platform? Metaverse platform is basically a developer environment. We can imagine it as, like, for example, Android or iOS that can anyone utilize who are developing applications for this environment. You can see the 3 most mentioned metaverse platforms here: Decentraland, Sandbox, and Roblox. The main difference is if they are decentralized or centralized. Decentralized are mostly running on or powered by blockchain. Centralized are not running on blockchain, and this is the way how can telcos play, creating centralized metaverse platforms. And what we can see, the South Korean telecom already developed their own metaverse platform. It's called 𝗦𝗃𝗏. And just to feel that how much market opportunity is this. The beginning of the year, 𝗦𝗃𝗏 had around 3 million users. And in October, they reported 12.8 million users already in the 𝗦𝗏𝗏. And this was before, and 2 weeks ago, they announced that they will launch in 49 countries around the world through partnerships. And the other really interesting aspect that, and what shows that there will be multiple metaverse, is that 𝗦𝗃𝗏 already started to position themselves as a K-pop content provider. So they are already positioning themselves somewhere in the metaverse, and not to try to grab everything. This is how they will able to charge the users by providing content, and the other way to charge the users is that they are created 𝗦𝗏𝗏 Studio, which is a creator environment. People can design their own avatars, items like clothing, accessories, shoes, and everything, and their own spaces, chill out spaces, or even like entertainment parks. So just to wrap up, I think metaverse is a really good opportunity for telco companies, even as an infrastructure provider, but they need to find ways to monetize it the right way. Otherwise, hyperscalers will take their market share. Thank you for your attention, and please contact me if you have any questions or do you need any more information. Thank you.
Brilliant stuff, 𝗏𝗏𝗪𝗏. Thank you so much. Now, moving on to the next speaker, let me introduce 𝗬𝗏𝗪𝗏 from Gurugram, Haryana, India, to present on 5G beyond connectivity. Over to you, 𝗬𝗏.
Hey guys, not too many slides. I tend to keep things very simple for myself and for the readers and consumers and the guys who are joining. I personally think that we are at a junction where things which are happening haven't happened to us before as an industry. Cloud is becoming real. The application stacks are going beyond OTT. The consumers want more than data and connectivity. They want experience. And then we are at a junction where the operators and CSP should ask themselves the question, what is the future of connectivity? And who are the future customers? Will it be still the B2C or B2B to X? Would there be enterprises also? And what product services the new consumer will consume and buy? Are they evolving their network architecture toward that vision? There are different examples where people have started building, the operators have started building their own platform. So would they follow build versus buy? Do they have skills internally or helping partners to build the change and reach out to the North Star? And what are the KPIs milestones they're tracking and the right trajectory to do that? On the left side, I've shared a very high level version. Maybe it will require double clicks, but happy to do that in the future. But on the high level, there would be an experience intent layer where the future customers would interact with the telco, where they'll buy connectivity on the runtime dynamically. Could be a marketplace, could be a portal, could be beyond that, could be an SDK dev portal, where they'll push their intents to say, I want a 10 Gbps link of a certain QoS for next 2 hours. The second layer would take that into a module like a CFS. Consider that automation, orchestration, RIC, CI/CD, whatever we want to. That will convert the CFS into an RFS or the real configuration on the network. And the third layer would be the network exposing the APIs. And then they might be simplistic with unified inventory, unified orchestration, and whatnot. If we have to support all this becomes necessary because you cannot activate multiple slices and still manage, capable of managing the non-slice users. You still have to give them services. You still have to give them the experience. So when I see of 5G and beyond, I think it's very important for the organization to figure out their future customers and their future needs, and how their architecture and capability should evolve to that. Maybe all of us have seen this. The 6G kind of reaches out to the similar thing, and it defines the next release or the architecture of the network, which obviously is disaggregated, sitting on top of cloud. The RIC kind of becomes very important. Security becomes important, and the sustainability and cloud becomes important. If you carry forward from the last slide which I presented, we have to start making those investments today, and the architecture should evolve towards this. And all the use cases which my fellow peers just mentioned about latency, about metaverse, about whatever the consumer wants to consume in the future, would require the network to support a lot more than connectivity services and a lot more dynamic product catalogs. Today, you might also have to take calls on standards and use cases. So tomorrow, if you want to enable use cases, and it's a little different this time, that do you watch standards or you watch use cases first? And I'm a firm believer of use cases versus the standards, because standards for me are a little, moving along, but sometimes they are just acting as references. There are things which are happening in the industry which will require some disruptors to take the lead. So look at the use cases on the right side. If you have to support all these use cases and still follow up the standards, even you have to contribute or evolve the standards, what all you can do. Considering the same architecture which we presented on the first slide, there should be an app dev portal. A lot of operators, tier ones, are already working on that, and knowing them, I see a lot of them have this also in their roadmap. The orchestration and automation, which is the usual orchestration slice, catalogs, OSS services, and then the SMO++, which will give you not the split brain architecture which is being evolved into the standards. There is RIC, there is SON, there is OSS, there is policy management, there is catalogs, there are NWDAF and whatnot. But for me, I think if you can consolidate the brain, the management and network exposure becomes much more independent. Obviously, it runs over ubiquitous and unified inventory and the infrastructure as such. I think these are some of the features which I thought, given the time, we should think about, not only in terms of the use cases, but how do we want to evolve now or in future, because it would be a journey. You cannot just replace your platforms and your current service stacks and application. Forget about the human skills, because human also take time to evolve, and a lot of tier ones have legacy networks to support, and obviously they're providing services, they're providing ARPUs and whatnot. So this was for me, I think, a session where we all should look back and figure out what should our strategies, use cases, our consumers and their requirements would be in the future, and then align our architectures according to that. Thank you.
That was quick. Thank you, Rahul. That was a great presentation, a good explanation. Thank you so much for your time. I appreciate that. Now, moving on to the next speaker, let me introduce 𝗬𝘂𝗽𝗍 Sawan from Plano, Texas, USA, to present on ambient intelligence in 5G advanced. Over to you, 𝗬𝘂𝗽𝗍.
Okay, the Internet of Things is a well-established paradigm for network of tangible and concrete things that exploit the existing internet infrastructure to interconnect over a variety of protocols, domains, and applications. The study of how an IoT system will integrate and interact with the users is tackled by ambient intelligence. And this is done to focus on transparently and intelligently support the users. Therefore, an AMI or ambient intelligence system should be responsive, sensitive, adaptive, transparent, ubiquitous, and intelligent. Hi, my name is 𝗬𝘂𝗽𝗍 Sawan, and today I will present on ambient intelligence in the context of 5G advanced networks. This is the agenda for today's presentation. 5G Advanced brings a new way of technology innovations, and that brings in that pushes the boundaries of into three broad directions: the performance improvement with integrated access and backhaul, the efficiency management and operations using artificial intelligence and machine learning, and finally exploring specific use cases such as edge and XR. The ambient intelligence is a system that can be considered as an intersection of artificial intelligence, human-computer interface, ubiquitous computing, and sensor networks. It can be further classified into two broad categories: ambient IoT and robot-assisted ambient intelligence. Okay, so what is the motivation for applying ambient intelligence systems in the context of 5G advanced network? The four major cyclical steps in an AMI system are sensing the environment, users, and the cloud, reasoning about the sense data, acting on the environment and users towards the users, and sending the feedback to the users to keep them in the loop. The motivation of AMI development in 5G advanced network is to combine the leverage of energy harvesting, IoT, sensing, cloud technologies, and build a sustainable and resilient system. Ambient IoT. Ambient IoT is an IoT service using ambient IoT devices that focus on energy harvesting, being either battery-free or using limited energy storage capability. Now, this enables communication with IoT devices that do not require the conventional power source and can avoid the hassle of manual replacement or recharge. The energy is harvested using either heat, light, motion, vibration, or radio waves. Now, radio waves can be converted into electricity using a process called as rectification. The challenge here is that the energy generated is extremely small, and it is not sufficient for all applications. However, the advantage is still that you can do this at the lowest cost and with smallest sensors, and use certain devices that can harvest this energy by attaching them to the items such as packaging, merchandise, or other materials. So this slide shows 4 examples of ambient IoT applications. The first one is an automated warehouse. Second is a smart power grid. Third is an airport gate terminal. And finally, a shopping mall. The top left corner shows the example of ambient IoT platform developed by 𝗰𝗋 organization. And this was demonstrated at MWC Las Vegas in 2022. The battery-free IoT pixels, these are basically stamp-size computers that are capable of generating power by harvesting radio waves. Beyond just the IoT chip installed in these pixels, and despite the size, we have another format, which is battery-assisted IoT pixels, which do carry a power generating capacitor to store the energy. And this one is also capable of sustaining a longer lifetime of about 4 years. So both IoT pixels are capable of maintaining the same small form factor of the size of a postage stamp and can be attached directly to the items on the production line at speed and in volume, similar to a regular label applicator at a department store. The second use case or design option is a network of service robots with ambient intelligence. This is basically to develop an efficient communication service and also a platform for using a group of communicating service robots. Now, there are three types of robots that are supported. Service and delivery robot, which is used to deliver an item to the customer, such as elderly care facility, hospitals, hotels. Hazardous control or underwater robot, which can assist the officers in dangerous situations, and shopping assistance robot, which can support the customers with different product information. Now, the characteristics of a service robot is different from an industrial robot. Service robot is capable of interacting with the humans, as opposed to an industrial robot, which is designed to replace humans on the production line. A service robot can exchange messages with humans using natural forms of human input, such as sentences, facial expressions, words, and the industrial robot is only capable of accepting standardized and structured inputs. So besides the basic areas or duties of a service robot, the service robot is expected to step up as the technology evolves, and we will see its applications in advanced systems such as zero-touch operations. Okay, so we are just done with release 17 and the requirements were frozen, and we are about to embark into release 18, which is defining the 5G advanced requirements in 2023. The ambient IoT and service robot system is planned to be included in release 19, and we will see study items for both the ambient IoT as well as the service robots. In conclusion, many industries are leveraging the advanced mobile technologies to solve their challenges and build efficient, scalable, and cost-effective networks. Ambient IoT, which cost about as low as 10 cents, is going to serve as a powerful data collection point in the future. Service robot network is also going to provide a platform for complex interaction with human users. Looking forward to the next wave in 5G advanced. And that's all for now. Thank you so much for your attention. Back to you, Ganesh.
Great stuff, Uttara. Thank you so much. I appreciate that. Now, the next speaker, let me introduce Alex Zomora from Singapore to present on future industry trends of 5G, including Web3 and Metaverse. Over to you, Alex.
Hello, everyone. I hope you can see my screen. So I'm going to give an insight about how industries, different businesses can generate efficiencies using 5G. I just have to provide a caveat that I have worked on various projects for GSMA, so my point of view is from the GSMA, but I'm not representing them. The information that I'm providing is on the public domain. So a little bit about the evolution up until now. We have seen it from various angles already. So there was this emergence of intelligent connectivity from the 3 and 4Gs. We moved into 5G, and there is a fusion between AI and IoT that creates this perfect storm of which various companies and industries can take advantage of. But some operators and some companies are reluctant to do it just because of the high upfront costs. And one of the the missions of the Global Association of the mobile industry is to provide evidence of how to generate additional revenue, reduce costs, improve efficiency using 5G as a solution. In terms of how to categorize these target industries where it could be applied, I'm just showing a couple of arbitrary categories. So on the right, you can see that we can talk about entertainment, about transport, various public services, industrial productivity, sustainability, and connectivity. Or other kind of categories, how we can think about it is how 5G can improve smart production, energy, our living, the way we entertain ourselves, and productivity in general. Industries can vary from manufacturing, mining, logistics, construction. And I'm going to show a few examples later for energy, transportation, government solutions, gaming. We saw a few XR solutions as well, and productivity in terms of our way of working, Web3 and metaverse. So if you dig deeper into where 5G can be used, I'm just going to show you a few examples. One of the tasks I was given is to create the world's largest 5G case study repository. So I'm working on that. I am halfway through. My target is having around 100, and I'm going to achieve 50 of them from various operators and businesses, hopefully by the end of the year, early next year. And that's something that if you're interested, you can find it at GSMA or obviously at the Mobile World Congress, which we heard about, and other presenters will talk about it as well. So some examples, I remember living like 15 years ago in South Korea and already being impressed by their connectivity. But right now, if you sit on a subway, you can even watch videos in 4K, which is not just entertainment, but it can improve productivity, which can be calculated as a additional earning or contribution to GDP as well. We know how painful, for example, when we are at a stadium and we try to connect to the internet or just use our phones. So Verizon was working on transforming this sport experience and also add additional benefits of different solutions through which people can purchase or just get additional information about the game itself. Drones and IoT benefit greatly from 5G. One of the solutions from Singapore, where I am right now, is that there are digital twins that can be first mapped and created using drones and then additional proprietary software. But indoor and outdoor drones can improve sorting, manufacturing, and delivery services as well. Some other solutions that I can think of and show here is that we have a few healthcare solutions. Also, VPN and connectivity can improve not just everyday work, but learning as well. Mining, which is a quite dangerous activity and also quite expensive. 5G can provide safety, security, improve some of the KPIs, reduce staff, and make sure that everyone is safe. So if we move on, another example is brainless robots, which I just thought it's an amazing name for some of the solutions that Naver in South Korea is using. It's a connected system of IoT devices that are using 5G and then helping the efficiency within some of the buildings. I wanted to show and share some of the Web3 and metaverse related solutions and just talk a little bit more about them. We heard of XR solutions. Obviously, right now it's a bit more clunky. There can be some latency issues, but as technology improves, even the devices that we have to wear, the haptic gloves and the Oculus or any other devices to see through the metaverse will be easier, and then 5G will just make it seamless and really immersive as an experience. We can already learn in the metaverse. In fact, I am also attending some NFT courses right now from Singapore to Cyprus, which is also thanks to 5G can be improved and make it more lifelike. So one of the solutions here is from Telefónica and Nokia and the IE University in Spain. And one of my favorites is a live theater that was using a 5G solution. Their pain point, this one is in Taiwan, their pain point was that there are not enough people attending the theater, and it's also from a very specific target group. So they wanted to widen their target group and also make a huge production, which is different from the previous ones. So they set up an area where various parts of the theater piece were played out. There were also huge screens. People could interact with that and also tap in and look into different parts of this performance. And all of this was supported by a 5G millimeter wave solution. If you have time, check out a link. It's pretty impressive. Another solution is how we showcase now business case studies is usually quite dry, a couple of videos, something that you print out, but what if we can use the metaverse for the same, for learning and also to showcase in a business environment. So one of the projects I'm hoping to do in the future is when I'm creating some of these solutions and trying to convince businesses, I could just invite them into one version of the metaverse and choose some of the winning solutions and bring them alive using a mix of tools. What's going to come next? We heard of 5G Advanced. In some rounds, it's called 5.5 and 6G. It's going to be new use cases just by reducing latency, just by having a larger capacity. There will be such new ways of benefiting from the solution that right now we cannot even think about. Not just the existing use cases will be easier, but there will be other parts of our life that will be just more comfortable and also put on a speedier kind of solution. So that's all I wanted to share. Thank you.
Thanks, Alex. That was great. Great stuff. Brilliant presentation. It was very informative. Now, moving on to the next speaker, let me introduce 𝗦𝘂𝗽𝗽𝗃 from London, UK, to present on 5G, 4K, and 8K video streaming and AR, VR. Over to you, 𝗦𝘂𝗽𝗃.
Thank you. Please may I share my screen?
It should work now.
Okay, hello everyone. So my name is 𝗦𝘂𝗽𝗃. I'm from London, the UK. I currently work for 𝗦𝘂𝗽𝗃, which is a motion capture company. And you should definitely check them out for real-time motion capture and also motion capture enabled by iPhones. So today I'm presenting on virtual reality and AR that's enabled by 5G technology. So currently, to fully appreciate the benefits of virtual reality applications such as gaming, users require expensive hardware, for example, high-end PC and gaming consoles and a head-mounted display. This is because VR applications require a large amount of processing power and storage, mainly for visualization of virtual scenery in order to enable truly immersive experiences. As a result, users of VR are confined to a particular location, and mass adoption is so far rather low due to the high entry barriers such as equipment costs, bulky headsets, and difficult usability. Although the first standalone VR HMDs no longer require an additional PC, their graphics visualization capabilities cannot yet keep up with expectations of users, especially those who are accustomed to 4K TV experiences. Augmented reality experiences are available today on either smartphones and tablets or on AR glasses such as HoloLens, which allows hand-free usage. Due to limited computing power and field of view, however, the overlay and interaction between digital content and the physical world lacks harmonization. With the arrival of 5G, the required capabilities to support AR and VR can be moved from the PC or console into the edge cloud, resulting in a lightweight and inexpensive headset that can provide quality on a par with fixed equipment. This is cloud AR VR streaming technology. AI technology is expected to be more essential for AR than it is for VR. AI allows computers to understand what they're seeing through the cameras, identifying and labeling objects in the user's field of vision. With the continuous advantages in AI, these features will become increasingly sophisticated. Together with fully functioning 5G networks, AI could enable a whole new wave of deeply integrated AR experiences. AR is a natural evolution for mobile phones. Statistica estimates that the value of the AR market will rise to almost 200 billion in 2025. Critical to realizing the benefits of cloud AR VR is a lightweight client approach, i.e. an architecture where the device can leverage cloud technology to supplement processing, storage, and application execution away from the cloud. AR VR technology will become truly mainstream with a broad-scale adoption of 5G networks, thanks to the convergence with the cloud and the incredibly fast, low-latency data connection. This combination will allow delivery of ultra-high resolution 4K and 8K viewing experiences with a low motion-to-photon latency. In contrast to today, where content is typically downloaded and rendered on a device, with this new architecture, it will be possible to stream pre-rendered video content to users on the move. 5G technology will deliver all these demands via its new network capabilities, providing a more reliable experience with ultra-low latency service through edge cloud technology. The current family of 𝗕.26x codecs suffer from high latency, which is mainly caused by the following reasons. The encoding, transmission, and decoding are performed in a serial mode. Only after the entire frame is decoded can it be delivered for terminal display. Occurs during network transmission. In order to suppress screen flickering due to network jitter, a large buffer is used before decoding. The decoding time of different frames also jitters. Therefore, to alleviate screen flickering caused by decoding time jitter. Coding time jitter tends to be long system running status, such as latency between the data is written and when it is exported from hardware and software, the latency to perform audio to video synchronization. In order to overcome those limitations, new codecs are required. There are interesting solutions already emerging that can drastically reduce the latency at the expense of increased bandwidth. This is a trade-off that becomes feasible as networks evolve. Still, those new codecs lack standardization, resulting in limited support in hardware and its devices. VR and AR require efficient increase in wireless capacity. A uniform experience is paramount for AR and VR. Network complexity will increase exponentially. Network slicing and traffic management are the tools to realize the full potential of 5G. Traffic management is key for the achievement of 5G QoS goals. Network capability combined with traffic policy guarantees the fulfillment of QoS indicators. Traffic identification and measurement are crucial elements of creating high-quality network services. With network slicing, a 5G network will be virtually split into several logical networks that can be tailored to the specific quality requirements of applications and services. Network slicing could be used to provide internet access, IaaS, with different quality of QoS levels and non-IaaS services, providing an adequate resource distribution. Our vision for 5G is a unifying connectivity fabric between enhanced mobile broadband, mission critical services, and massive Internet of Things. New ways to watch sports is another domain where AR/VR is already being tested and put to use. Think about video assistant referee VAR technology in soccer and Hawkeye technology in tennis. The way we watch sports is changing and is leading us into the next generation of sports consumption, but the enthusiasm for immersive media in sports varies across countries. 27% of respondents in Germany state that VR in sports brings the most value, with 68% in India reporting the same figure. In general, AR and VR in sports is more popular among millennials. Just as we discussed for music, VR technology can transport a consumer from a living room to a stadium, giving viewers a choice of camera angles and the option to retrieve stats and information about specific players. A VR headset and an app are all that's needed. Stadium quality VR viewing is already evolving. For instance, the US wireless provider Verizon hosted a VR Super Bowl stadium experience over a 5G connection to a limited group of employees and the British Broadcasting Corporation, BBC, offering an app providing a VR FIFA World Cup experience in 2021. Though we are only in the infancy of AR/VR, the technology is quietly revolutionizing live action sports. Consider on-player camera feeds enabling consumers to view the action through the eyes of the athlete. Many opportunities are yet to be discovered, and we can expect unanticipated possibilities with the rollout of 5G networks. In addition, stadiums themselves can become technological wonders filled with new technology to enhance the fan experience. Both AR and VR bring many practical applications to M&E. Interest varies across age groups and countries. AR applications in music and concerts are very popular among Gen Z respondents and the younger millennials. Respectively, 68% and 58% stated these applications bring them the most value. Indeed, in the era of elaborate music festivals, AR is becoming a common feature, adding to the music industry's cutting-edge vibe. The latest technological advances turn live concerts into high-tech experiences that wow the audience. For example, the theatrical element of a stage shows can be radically increased by partnering AR-generated characters from songs with real live artists on stage. Sounds, images, and special effects, as well as the general atmosphere, all play equal part in entertaining participants. The latest technological advances turn live concerts into high-tech experience. As could be expected, Gen Z and the younger millennials are intrigued by immersive media and music. In general, the demographic prefers spending on experiences versus material things. They are very enthusiastic about VR applications as well. VR can make music fans feel as if they are actually present at the live concert and allows them to watch the show from different virtual positions. The music industry is testing many other AR and VR applications and steadily exploring how to incorporate AR and VR into innovative experiences. Automatic video streaming is another possibility, plus remote control and tactile internet. Overall, we think 5G is essential for the next-gen AR and VR experiences. Thank you very much, and I'll pass on to the next speaker.
Great stuff, Francisca. Thank you so much. That was so much of information. It will be very helpful for the audience. Great articulation. Thank you again. Now, let me introduce Terence Wong from GSME Hong Kong to present on the GSME APEC 5G industry community and IoT. Over to you, Terence.
Thanks, Ganesh. Can you hear?
Yes, sir.
Okay. So myself is Terence. I'm based in GSMA APAC region. Today I'm going to share you what I'm doing in the region, which is creating a 5G industry community for ecosystem collaboration for joint success. So I think, as most of you are aware, actually 5G commercialization happening in the last 3 to 4 years time. So there are already over 218 operator roll out 5G in more than 83 market. So there are many operator, and then for FWA 5G also already 84 operator. And then for 5G SA, there are also over 31 operator, and then nearly half of this is from APAC region. So 5G industry community, actually, we are evolved from the IoT community since last year, and then we start to supporting government, enterprises, mobile operator to understanding the 5G technology. And help them to accelerate the rollout, especially for enterprises, industry use cases across manufacturing, healthcare, logistics, port, and transportation. We work very closely with different government department and agency and manufacturer and operator in the region. So just show you a quick video to review what we have done. So as you can see, actually, we did a lot of virtual and physical activity, including 10 workshops already for 3 different industry sector, over 100 digital pioneers sharing their experience in their 5G journey. So 5G actually is just is still an evolving technology. So we really need to build an ecosystem. So far we have more than 700 organization members in our community. Over more than 66 countries. So we produce case study. These are all public resources. If you want to know more about 5G in this region, welcome to download this case study and participate in our activity. As I mentioned, we are very focusing on manufacturing, logistics, transportation, and healthcare with different reasons. Of course, this sector are very important in this region, and also there are strong momentum from enterprises and also government authority in healthcare, in transportation. They are looking forward for digital transformation using this 5G technology. I think previous speaker also mentioned, mining, metaverse. Of course, this technology can be built on this sector for different kind of use cases. I think the community is a very good community. We have government, we have enterprises, mobile operator, and ecosystem along the value chain. So they all are very willing to work together to generate the insights and idea. I think especially on some government policy, how they could work together to accelerate 5G adoption. And then, of course, we need a lot of innovative people together to create a platform, divide the API, especially for interoperability to support, different kind of use case on top. And we also work with government to build up the local 5G alliance to support ecosystem development. I think we have a website. Welcome to visit our website to access the information and join our community. If you join, of course, you can receive our regular newsletter. Here are some of the case study I just mentioned. We have worked with our stakeholder in the region to produce case study on how 5G applicable for seaport, for hospital, for factories, for warehouse in different countries. This past activity, we have put it into the website. Welcome to access these resources if you want to understand how 5G being adopted in the region, how 5G benefit for different sector. As I mentioned, there are already a lot of pilot cases in airport, in seaports, in hospital, in warehouse, in factories. So moving forward, we are working with the local government operator and also enterprises to build up different kind of local 5G alliance. I think the small success in each market will help to work together to build up the scale ultimately to drive down the cost, and of course also create the competition among different solution provider or different market. I think this is very good ecosystem. We also work with our global partner through our headquarter team in GSMA London with 5GACIA, 5GAA, or Global UTM, or Auto Medicine Association. They are all a very specific industry association which focusing on manufacturing, automotive, healthcare, and also UTM. So finally, just share you our next calendar year activity along the whole year. So welcome to access to this activity, of course. If you are interested, just visit our website to join our community. If you're very good, of course, we will provide you a speaking opportunity as well in our activity or case study. Thank you very much.
Thank you, Terence. That was a great stuff. Appreciate it so much. There's a lot of things happening in GSMA, in APEC. Very well informative. Now let me introduce our last speaker, Erik Sandberg from Uppsala, Sweden, to present on innovative 5G sync solution. Over to you, Erik.
Thank you very much. Can you see my screen in a minute?
Yes, it's working.
Okay, good. Good morning, good afternoon, good evening. I'm Erik Sandberg. I'm going to talk about the precision time net, or so-called PTM. I work as business development at 𝗬𝘃𝗽𝗃 in Stockholm. And my background is 10 years with Huawei and 10 years with Ericsson and a couple of IoT companies in between. So extensive 5G expertise, actually. Okay. And a couple of words about 𝗬𝘃𝗽𝗃. We have 25 years of experience in actually large live events. So if you're watching the World Cup in Qatar right now, it's through the equipment supported by, provided by 𝗬𝘃𝗽𝗃, actually. Company was founded in 1997, and we have a lot of high-end customers. Some of them you can see on the right side of the screen. We're present in 70 countries, and we have been doing GPS independent time synchronization solution in over 20 nations in the digital TV networks. And it happened to be that the requirement for digital TV terrestrial network is the same as in 5G. And why is time synchronization so critical in 5G? Yes, first of all, it's because 5G is TDD compared to 3G and 4G, which is FDD. TDD stands for time division duplex, and that means that you have one single frequency band with both uplink and downlink traffic. So you can imagine that the time synchronization is very important. It's not only frequency, but also phase accuracy that you need. Secondly, because of TDD, you can use actually massive MIMO with much higher capacity than FDD. FDD cannot provide the same uplink knowledge about the channels that the TDD can do. So those two are important for 5G and new key drivers. You have, of course, GNSS or GPS, which is commonly used, but it is vulnerable to jamming, and I think especially our geopolitical situation in Europe right now, it's actually a trend to be independent of GPS. For example, the Swedish authority government have issued a mandate that all 5G networks should be GPS independent. So what you do, you can use a fully synchronized network where network or full time support called PTP, Precision Time Protocol. It's the classical way, but it drives cost and complexity in the network. So what do? We do time transfer from a source, which most of the time is in the core network, over to an access network or within the regional network. And also, if you have a so-called non-PTP network, we can transfer time from that point A to point B. And how do we do it? We do extensive sync telemetry and visualization compared to classic PTP. We send perhaps many thousand packets a second versus PTP that is doing 128 or even less packets per second. In doing so, we can also auto-calibrate for asymmetry. PTP actually measure the round trip time and divide by 2. And we can actually auto-calibrate for asymmetry. And we also benefit from multi-link and collaborative clocks and do advanced filtering. So we don't use the best master clock algorithm, but we use collaborative clocks information. And then we have an intelligent routing protocol, which makes this very redundant and reliable. And we then deliver the full PTP profiles to the end user, which in this case is, for example, a base station, according to telecom profile, a media profile, and power utility profile, according to these ITU specifications. And this is an example from Turk Telecom, where City A is to the left here with a lot of routers and switches, city B and city C. And these are sometimes PTP enabled and most of the time not PTP enabled, different vendors, different suppliers, different type of network elements. And over a distance of 1,200 kilometers, 11 versus 14 hops, we deliver time accuracy with plus minus 300 nanoseconds over 10 days. Actually, we normally are within 100 nanoseconds, but it is more fair to compare what we do over 10 days. And to the left here, you can see the budget for 5G, which is the time alignment error of 1.5 microsecond. And to the transport, we have a budget of 1 microsecond because the front haul need another half microsecond. So these are measurements from proof of concept work that we have been doing or ongoing. So examples from the core is that we are within 100 nanoseconds, which is normally for the core. If you go out to a regional network, it's a little bit more, 150 nanosecond. If you go over core network and microwave links, it's still 100 nanosecond. I would say we're pretty good in doing microwave transmission as well. Sometimes depending on the manufacturer or the vendor of there. And this is a measurement over 3 days. As you can see, you have a variant over 24 hours here. And we're still within the budget of 250 nanosecond. But in this case, our customer could point out that the host of the leased line actually had a problem in delivering accurate time to his base station. And in terms of cost, this is a cost comparison from one of our customer, a communication service provider, with an estimated plan for a TDD rollout in approximately 1,000 mobile sites in a region. And as you can see, if we compare PTP cost and PTN cost, we are a fraction of that actually, down to 60% of that cost. And then we have not included the operational cost, the cost it takes to do the inventory to switches and router ports, which you then have to update, and no installation and commissioning is included as well. And as you build out the network, you can see that PTN is always going to be more cost efficient than classic PTP. So in a nutshell, what we do is that we deliver precision time net. It's reliable. We do precision time protocol distribution over an existing IP network. We deliver PTP extension according to these classical profile specification. We are doing excellent for leased line and microwave. It's affordable because of the cost savings, and we're GPS and GNSS independent transport of the UDC. And we're actually, maybe this is the most important, we're sync probe. You can get in charge of your network and sync network, and you can actually use this as a probe to verify the quality of the time in your network. And the way we do it, we use mesh network in mesh IP network. It's resilient, redundant, and robust. So, in summary, PTP is the extender for fast rollout, large capex saving, no forklift upgrade required, high security and reliability because of GNSS independent, no need for GNSS at each site. It's open and disaggregated. We're actually agnostic to the equipment that is in the network. It's independent of infrastructure and vendor, and it works over leased line. And I see that I may have a couple of more minutes left. So maybe I can just tell you a little bit what our new contract. We started first with 𝗘𝘃𝐺𝗵𝗃𝗁𝗃. And as you can understand, because of jamming in the Syrian war, 𝗘𝘃𝐺𝗵𝗃 was very excited when they found out that they can reuse actually the media time synchronization equipment provided by us into their mobile network. So because of that understanding between the two, I would say two industry worlds, in media and 5G, we actually got the request from 𝗘𝘃𝐺𝗵𝗃, why don't you bring this technology also into the 5G world? And today we're proud to say that the operator Hutchison-based 3 Sweden is also signed a contract, and we have also a Canadian operator just signed a contract recently, and we hope to be able to sign more contracts in the future. With that, I would like to thank you very much for having the opportunity to give this presentation. Thank you very much. Over to 𝗘𝘃𝗃𝗃.
Thank you, Eric. That was great. Well done. Thank you so much. Appreciate that. So maybe let's take about 10 minutes for each of us to have Q&A among the speakers. Maybe I could be able to start first. This is something that was playing in my mind for some time regarding about 5G monetization. I just want to focus on the challenges currently that the mobile operators are facing in terms of deploying the 5G from a monetization point of view. The question that I have in my mind, based on 2 or 3 some key analysts in the LinkedIn who never have agreed or who never have supported the existence of network slicing or slicing as a service. So my questions on the floor, based on your experience with the mobile operators, do you think that slicing as a service will kickstart and that will give a very strong momentum in terms of the monetization?
Maybe I can get starting on that. Slicing is a big advantage of 5G, of course. And if you look at the applications and on a core level and everything, where networks are going to be virtualized, it's an excellent idea. But we have been dealing with quality of services for over 10 years in 4G, and it hasn't been used in that sense before. But I think with verticals and enterprises that is coming up in 5G, we will actually benefit from having a more end-to-end quality of service. So definitely it's here to stay in 5G. But it's going to take some time together with the development of the enterprise market, I would say. And talking about, since I'm working with RAN, slicing out to the metal in the antennas is not even possible. So what RAN is doing is actually some kind of slicing aware features that is dealing better with quality of service. So you have, in principle, the way you book resources in resource blocks in the RAN could be soft or could be hard, or it could actually be also that you have a dedicated frequency for your own. In that sense, it will be some kind of slicing, but I wouldn't say it's 100% slicing, call it that way.
The other area, I mean, in the monetization as well, I believe the average price per month usage is about, if I'm not mistaken, this price is based from the Europe price levels between 90 to 110 USD per month, which is considered quite high if we compare to the 4G. I believe in future, there's a lot of efforts are taken also to how to minimize those price levels, right? Like countries in South Korea, like South Korea Telecom have invested 5G for the last 5 years. They haven't came to a break even based on the amount of investment that they have done. So it's going to be a challenge in terms of juggling between the cost of the infrastructure and also the ROI. And obviously it's not as we can compare as with 4G or 3G, because it was very much consumer driven, but 5G is very much industrial driven. So the question is how quick we can able to get those ROIs. It's always a question.
For example, in 4G, we actually tried as a vendor to push for operators to use quality of service mechanisms to provide gold subscriptions and exclusive subscription, gold, silver, bronze, actually. But I don't think it ever happened. Most of them are running non-GBR rates. But the difference is that was video and voice. The difference now is that you go into low latency services, you go into enterprise 5G private networks, and so we're creating another model now and business model for those kind of systems. So that will be the game changer, I would say.
Yeah. So anyone? Yeah, please.
Yeah, I think for me, I would see actually, I think we all agree 5G is evolving technology, right? As at the very beginning, you see operator rolling out 5G non-SA mode, which is still very consumer target, right? Until I think the release 16 come out, and then the operators start to roll out the standalone mode, which allow end-to-end network slicing, right? I think this is very fundamental for dedicated the resources end-to-end and the low latency features to the enterprise and industry. So that's why I would say if you talk about release 16, it actually is not really long time, right? We got into the commercialization. We are seeing the momentum with the operator rolling out. As I mentioned in some figure, there are around 30 something operator roll out SA mode only. So it means that if you count it from this point, it is still very early. I think the industry really believe 5G is really changing the world, and that's why people now start to develop 6G as well. I think it's kind of trust and belief. So if we back to the history, we look at 3G, right? When 3G start, every people, wow, 3G will be killing the world, right? Mobile internet. But turn out actually 3G is not really success. I think because it's very beginning to talk about mobile internet by that time. The technology needs some time to develop and to be mature. And then 4G actually is really the success for mobile internet. I would like to highlight that it is a time, it's a time development throughout the 3G jump to 4G. You see the exponential growth when 4G become mature of the 3G, right? I believe it will be very similar for 5G. It will keep improving the technology. And also, I think the enterprises need some time to understand the technology, and that's why there are so many pilots around the world, so many cases. The momentum is here. I think monetization will be something to come, but just investment is necessary. If you want to make 5G as a success as a consumer market, I think it will be really long time. I think operators have to also develop a more easy way for enterprises to access the resources, right? More robust, like open API, for example, and standardizing some API to access the network resources. So that just like a marketplace that enterprise can, use the open API from the operator to define their network resources. I think that thing will be also a triggering point to make scale, right? I think this is still quite early, honestly. So that's why I think I believe 1 to 2 year time, more this kind of things happening, more mature, and then will be scale up and then will be monetized. And then another things is also the ecosystem, the device side ecosystem. I think this also need to take some time to drive down the module cost for 5G, especially for SA or mmWave technology. But I think for the industry overall, when I talk to, I mean, it's not only to mobile industry, but also to manufacturer, automotive, or even department from different government. They are all quite positive still. So that's why I think investment is on continuously ongoing.
Maybe I would like to add a bit. I think we all want to see enterprises or large enterprises will able to start automate from their web for specific requirement of use cases or as in a slice of service, so that they could able to enjoy what they use, right? So pay as per use, and it's not as pay on a monthly fix for each SIM card or each user, right? So it's based on the whatever categories and the KPIs and what kind of use case based on the EMMB or the URLFC or the MMTC types. And with that requirement, then they can able to custom made and they can able to enjoy the best of ROI, right? So that also will cut costs for them as well. So I think this is something that we are all looking forward, which may take some time for the mobile operator to be ready on the end-to-end network slicing as well. Anyone wants to add? Or anyone have any other questions? Alex, I just want to ask something, Alex. You know, the venture capital that you are involved in, how is the response from the public in terms of the startups? Obviously, yes, 5G is ultimately is enabling, but do we have enough of startups coming out with various of use cases that's really kicking off in terms of demand in Singapore?
So specifically in Singapore or Southeast Asia, the companies I'm looking into are not necessarily related to 5G. GSMA has an arm that is looking into projects that are in collaboration with various mobile operators, but they are usually mobile for development and can leverage from 5G, but probably it's in countries where 4G is more prevalent. So I'm looking into some deals which would be related to cutting edge frontier or Web3, but their connection to 5G is not that obvious. I think the adoption is still yet to come, although Singapore specifically is quite a leader in that case. So they are working on some solutions. I mentioned, for example, digital twins, but there are other governmental institutes that are creating projects, but they are not necessarily startups. They need big funding, and they are partially government institute funded. Yeah.
In terms of the metaverse, a lot of huge hypes in metaverse, right? Are there any startups that started building own metaverse applications?
There are various use cases, not necessarily providing product market fit yet. So yes, some of them in terms of education, that could be a great platform, even to simulate any kind of social activity that are now done on Web2 social media platforms could be then migrated eventually to Web3. And of course, nobody wants to miss out on it. So they all build a certain variant of it. Gaming industry is a big area where metaverse is relevant. The question and the critique is that there isn't a stickiness or a constant use of the service. But in my opinion, you don't have to. You have to create various events where people are coming and joining and consuming. And during that time, revenue can be generated or data can be used. So we have to start thinking about it slightly differently than how we use recent technological tools.
In fact, just now when Deepak presented on �ฬ𝗺 from South Korea Telecom, because they are the pioneers when it comes to the metaverse, some good news was that Singtel have actually partnered with South Korea Telecom to bring the �ฬ𝗺 as well in Singapore and also the Southeast Asian market. That is great stuff to start metaverse in this region. 𝗤𝗪𝐶, you have any point from a 𝗃𝗃𝐺 point of view in these future trends?
Well, yeah. I mean, this monetizing this metaverse, I really agree with Alex that you have to create events which can bring in users, and what I mentioned in my presentation in the �ฬ𝗺 is exactly what it does. That they are positioning themselves as the content providers for K-pop, and they are making �ฬ𝗺 available in more and more countries. So I think that will be a good way to participate in the metaverse, and a good strategy to make it widespread amongst consumers.
Yeah. I think one of the business model that 𝗃𝗃𝐺 that you presented earlier, that was very interesting when it comes to the how mobile operator wants to partner with the cloud gaming service providers, right? And mobile network operators be the agent towards the consumers, where they tie up special packages with the various of gaming service providers. I think that's a good trend to see monetization takes place, and some of the countries are really kicking off in gaming, like for example Saudi. Nobody believes that Saudi is one of the pioneer or lead in terms of the cloud gaming. Nevertheless, other countries are getting on track as well, like Thailand, Vietnam, or even in South Korea and Japan as well, right? So yeah, cloud gaming is another area that we can see a lot of potential in terms of revenue generation.
Exactly, I think cloud gaming will be. I mean, that will be a huge market. But just a personal note, I have my Xbox and tried the cloud gaming experience there, and it's still not that immersive and good than traditional gaming. So the resolution is not good enough. The latency is not low enough. So it's still not, cloud gaming is still not the same experience as traditional gaming. So there is a lot of room for improvement there.
Okay. Is it due to the 5G infrastructure or the application itself?
To be honest, I'm not sure about this, but yeah, I was using fixed infrastructure, so fixed connection, so wouldn't be because of the 5G.
I think when it comes to new opportunities in 5G, we're also curious to see what standalone networks will do. I think most operators, only 35 operators, I think, have launched SA. And so I think they're experienced now what we can do and what they can do with the SA compared to what's possible to do in 4G. And I think that will bring it a little bit further when we can see what we can really do over SA, actually. And I also want to mention that since we work also with the media broadcasting industry, there's a lot of things happening in the media side, actually events and arenas where cameras are being connected directly to 5G and you can do remote production. That is a big change now in the media networks because they can run the same thing doing the production remote instead of having dedicated buses and dedicated cameras on site and dedicated networks. So that change is ongoing as we speak, going more into IP and mobility and 5G. So I just want to mention that. So there are things going on. It's a very exciting times, actually.
Yeah, I think I just want to add on the broadcast part. So far as I know, that is really getting popular is the two mobile operators. One is the BT, British Telecom is really investing in the mobile broadcast, and the other one is Verizon from US as well. So
yes,
these two guys are really going all out. Maybe more, but these are the people that I keep on seeing in the advertisements. They're really going all out for the broadcast.
But we are waiting maybe for the really ultra reliable, low latency services coming up. I think that's the important 5G leg that we haven't seen much of yet, I would say. It's still enhanced mobile broadband and machine type communication.
Yes. Telefonica is quite active, and then OEMs are really in the game as well. So the Ericssons, the Huawei's, the Qualcomms that are really strong in the game.
The question is the devices. Do you think that all the devices are ready for specific requirements? As far as I know, like the 28 gigahertz, the devices were still not ready till now. That's because, you know, high range frequency with the shorter distance coverage, right? I'm not sure about other frequencies.
I'm not dealing with the devices that much, so should be some device manufacturer or some Qualcomm guy to answer that, I think.
I think for the 3.5 gig, that shouldn't be a problem, right? Because then it's very much on a consumer driven, so it's okay. Like, yeah, it's a mass market, so they can easily able to produce due to the demand. But as it increases, as the frequency increases, then of course the usage limitation is based to the industrial driven, right, rather than a consumer driven. So the question is whether, you know, the suppliers or the manufacturer wants to do it because of the limited demand, right? So that's also the cost factor of ROI for those producers again. So I think that's also giving the delay for the production. But let's hope for the best. I think there's a lot of hype as well for 2023. It is expected there's more devices, more than 100 devices are coming in the pipe. So yeah, so let's see. Let's hope that a lot of devices are available for the industrial usage as well. Anyone have any last question? Okay, if not, then thank you so much. Thank you for joining us.
Thank you.
This event, I really appreciate. I think this will give more traction towards the larger community around the world. We have a lot of universities, colleges, students, startups, verticals as our followers. And I believe a lot of them will benefit from this program. So to the audience, please do subscribe our YouTube channel, Global 5G Evolution. And yes, thank you so much to the speakers, and let's keep in touch. Have a nice day.
Thank you for the opportunity. Have a nice
Thank
day.
you.
Bye.
Thank you.
Bye.
Bye.